On November 17, 1944, at 5:47 hours on Peleliu Island, Corporal James Donovan, a 22-year-old Marine, found himself positioned inside a coral cave permeated with the acrid smell of cordite and death. His Thompson submachine gun rested in his trembling hands, feeling inadequate for the task ahead. Approximately 30 feet from his position, through a gap in the jagged coral rock formations, Japanese soldiers could be observed moving behind reinforced concrete pillboxes that had proven immune to nearly 2 months of sustained American assault. The standard .45 ACP rounds fired from his Thompson had demonstrated virtually no effectiveness against these fortifications. Over the preceding 58 days, Donovan had witnessed the deaths of 14 men from his platoon during attempts to neutralize these defensive positions. Flamethrower units had exhausted their fuel supplies without achieving decisive results, while bazooka rounds had deflected off the concrete at improper angles. The Japanese defenders had successfully transformed the Umerbogol pocket into a fortress complex that had inflicted devastating casualties on American forces. When Donovan's sergeant approached his position carrying a wooden crate stamped with red lettering identifying it as M1 Frangible Grenade Cartridge, experimental, authorized personnel only, the corporal had no understanding of what he was about to receive. The crate contained ammunition that appeared fundamentally different from standard rounds, with projectiles that seemed too long and too heavy, featuring copper-colored components where conventional bullets would normally be positioned. The sergeant instructed Donovan to load these unusual rounds, while mentioning that intelligence personnel had intercepted Japanese radio communications referring to something they called Bakudan Akuma, which translated to Boom Devil. Donovan possessed no knowledge of what these experimental rounds were capable of achieving. He only understood that in 6 minutes, when the scheduled artillery barrage concluded, he would discover whether these unusual cartridges could accomplish what 2,000 tons of naval shells had failed to achieve. The evolution of Pacific Theater fortification challenges. The Pacific War had created tactical problems that military planners had not anticipated when the Thompson submachine gun was originally designed in 1921. John T. Thompson's famous weapon, often called a trench broom, had been engineered to fire .45 ACP pistol ammunition, which proved powerful for engaging unarmored personnel in close-quarters combat, but utterly inadequate against reinforced defensive positions that Japanese forces constructed throughout the island-hopping campaign. By late 1943, American forces repeatedly encountered nightmare scenarios across islands including Tarawa, Saipan, and Peleliu. Japanese defenders who had been given months to prepare their positions had converted natural cave systems and coral limestone formations into interconnected fortress networks. Intelligence reports from the Battle of Tarawa in November 1943 documented bunkers constructed from coconut logs, coral aggregate concrete, and steel railroad ties that could withstand direct hits from 16-inch naval guns. The Marines suffered 3,407 casualties while taking an island measuring only 2.4 miles in length. American forces discovered defenders still alive inside bunkers that had endured 3 days of bombardment that had consumed more ammunition than the entire Guadalcanal campaign. The standard infantry weapons available to American forces, including the M1 Garand rifle, the M1 carbine, and the Thompson submachine gun, all fired conventional bullets designed to penetrate flesh rather than fortifications. A .45 ACP round fired from a Thompson carried 355 foot-pounds of energy at the muzzle, which was sufficient to immediately incapacitate an individual, but it deformed or shattered against concrete after penetrating barely 2 inches. The M1 Garand's 30-06 round performed somewhat better, achieving 6 to 8 inches of concrete penetration, but still could not reach defenders sheltered behind multiple layers of reinforcement. Flamethrowers proved effective, but required operators to approach within 40 yards of their targets, which represented a death sentence when every bunker had been positioned with interlocking fields of fire. Explosive charges placed by combat engineers proved effective, but cost American lives at a horrific exchange rate. During the Peleliu campaign, which began on September 15, 1944, engineers suffered casualty rates exceeding 40%. The 1st Marine Division deployed 9,000 men and suffered 6,526 casualties, representing a 72.5% casualty rate that exceeded Valley Forge and Belleau Wood. By October 1944, the Marine Corps had identified a critical gap in the infantry arsenal. No man-portable weapon existed that could deliver explosive force through firing ports, cave openings, and bunker embrasures from a position of relative safety. The Ordnance Department had been working on a solution since early 1944, but the security classification was so restrictive that even division-level intelligence officers remained unaware of its existence. The revolutionary ammunition design and development. The weapon system that arrived on Peleliu in November 1944 represented a radical departure from conventional ammunition design principles. Engineers at Frankfurt Arsenal in Philadelphia had spent 8 months developing what they officially designated the M1 Frangible Grenade Cartridge, which was a Thompson submachine gun round that carried a small explosive charge instead of a solid bullet. The concept violated every established principle of small arms ammunition design, but desperate circumstances drove innovation. Standard ammunition development cycles typically required 18 to 24 months from initial concept to field deployment. The M1 Frangible Grenade Cartridge progressed from drawing board to combat deployment in just 32 weeks, compressed by battlefield urgency and classified as urgent priority by General Douglas MacArthur himself after casualty reports from Tarawa crossed his desk in December 1943. The M1 Frangible Grenade Cartridge appeared unlike any ammunition Donovan had previously encountered, and for good reason. It was not ammunition in the conventional sense. Instead of a solid lead projectile designed to penetrate and tumble through tissue, each round carried a 48-grain charge of composition C2 plastic explosive encased in a copper-jacketed frangible projectile that weighed 180 grains, nearly twice the weight of standard .45 ACP hardball ammunition. The cartridge case itself was modified from standard .45 ACP brass but extended to 1.275 inches instead of the usual .898 inches to accommodate the unusual payload. The propellant charge used improved military rifle powder instead of standard pistol powder, generating 18,000 psi of chamber pressure, compared to the Thompson's usual 21,000 psi rating. Engineers had deliberately reduced pressure to prevent catastrophic failure when firing explosive projectiles through a weapon never designed for such stresses. The frangible projectile represented the revolutionary element of the design. Frankfurt Arsenal metallurgists created a compressed copper matrix loaded with tungsten particulates that would hold together during barrel transit but shatter on impact, releasing the explosive core. The projectile achieved 950 feet per second muzzle velocity, which was slower than standard .45 ACP's 830 FPS, but carried significantly more energy due to increased mass. The additional mass and velocity combined to deliver 361 foot-pounds, comparable to conventional rounds, but with an explosive payload that multiplied effectiveness exponentially. Inside the copper jacket, the 48-grain C2 charge surrounded an M42 electric detonator no larger than a grain of rice. The detonator used piezoelectric crystals that generated a firing impulse when subjected to the sudden deceleration of impact, utilizing the same principle used in artillery proximity fuses, but miniaturized to fit inside a .45 caliber projectile. The detonation occurred .003 seconds after impact, just as the frangible jacket disintegrated against the target surface. The ammunition came packed in reinforced wooden crates containing 200 rounds, with each crate weighing 37 pounds and marked with red hazard diamonds and serial numbers beginning with FA-EXP-444. Supply officers received special handling instructions printed on water-resistant paper that accompanied each crate. These instructions specified storage temperatures between 40 and 80 degrees Fahrenheit, no stacking above 4 crates high, minimum 50-foot separation from conventional ammunition, and immediate reporting of any rounds showing corrosion or deformation. Field testing at Aberdeen Proving Ground in Maryland during August 1944 had demonstrated capabilities that seemed impossible for a submachine gun round. Against 4 inches of reinforced concrete, conventional .45 ACP achieved 1.8 inches of penetration. The M1 Frangible Grenade Cartridge punched through completely, then detonated against the rear surface, creating a spalling effect that sent concrete fragments ricocheting through a test chamber with enough energy to penetrate 3/4-inch pine boards placed 6 feet behind the target. Ordnance engineers nicknamed the ammunition Little Devil during development, but security protocols prohibited informal designations on any documentation. The official specification sheet, classified as secret and numbered FM-OD-89144, described the round as suitable for engaging reinforced personnel shelters, light fortifications, and area targets behind intermediate barriers when fired from M1928A1 or M1A1 submachine guns. The Thompson required no modifications to fire the new ammunition, but the operating manual issued to units receiving the cartridges specified several critical procedures. Operators needed to fire in semi-automatic mode only, as full automatic fire risked barrel overheating that could potentially detonate unfired rounds in the chamber. Maximum engagement range was listed as 75 yards, beyond which the frangible projectile became unstable and could tumble or fragment prematurely. Each weapon could safely fire 120 rounds before requiring a 20-minute cooling period. The rounds arrived on Peleliu on November 12, 1944, on board the ammunition ship USS Wrangell, which had departed San Francisco on October 28, carrying 840,000 rounds, distributed in 4,200 crates. Division ordnance officers initially received no explanation for the special cargo, just orders to distribute it to Thompson-equipped personnel in companies engaged in cave fighting operations. Sergeant Thomas Whitmore, the individual who provided Donovan with that first crate, had attended a 30-minute briefing the previous day, where a harried captain from Ordnance explained the basics regarding explosive rounds effective against fortifications, the importance of not overheating them, and the need to maintain operational security outside their unit. Donovan loaded 15 rounds into his 20-round stick magazine. The cartridges clicked against each other with a sound slightly different from regular ammunition, producing a heavier, more substantial sound. The rounds felt strange in his hands, dense and ominous, with each one representing a small explosive device waiting for permission to detonate. At 5:53 hours, 4 minutes before the barrage would lift, Donovan chambered the first M1 Frangible Grenade Cartridge, feeling the bolt close with more resistance than normal due to the longer cartridge barely fitting the magazine well. His hands had stopped shaking. Around him, 6 other Marines crouched with similar loads, their Thompsons loaded with ammunition that their training had never covered. The naval bombardment from USS Mississippi reached its crescendo, with 14-inch shells screaming overhead every 8 seconds. Each shell hit the ridge above the cave complex with enough force to make the ground jump beneath the Marines' feet. At 5:55 hours, with 2 minutes remaining, Sergeant Whitmore provided hand signals for the firing sequence. 7 targets had been identified for 7 shooters. The bunker complex ahead sprawled across 200 yards of coral ridgeline, with each position connected by tunnels the Marines could not reach. Intelligence estimates indicated 140 Japanese defenders remained alive in the complex, many of them wounded but all armed and waiting. Donovan's assigned target was firing port number 3, a rectangular opening 18 inches wide and 4 feet off the ground, cut through 3 feet of reinforced concrete. Through binoculars earlier, he had observed the barrel of a Nanbu machine gun just visible inside, covering the approach to the next ridge. That Nanbu had killed 5 Marines the previous day. At 5:56 hours, with 1 minute remaining, Donovan's breathing slowed as Marine training drilled through months at Camp Pendleton took over, focusing on sight picture, trigger control, and follow-through. However, he was now firing explosives from a weapon designed to spray lead, and nobody truly knew what would happen. The USS Mississippi fired her last salvo. The shells impacted with sequential thunder that echoed off the coral, and then silence descended over the battlefield. At 5:57 hours, with 2 minutes remaining, Sergeant Whitmore gave the command to engage. Donovan rose from cover with his Thompson shouldered, front sight centered on that firing port 47 yards distant. He squeezed the trigger in semi-automatic mode, controlled and deliberate exactly as the briefing had specified. The Thompson recoiled harder than normal, with the recoil impulse sharp and sudden. The frangible round arced across the gap and impacted the target. The explosion was not loud compared to a grenade or satchel charge. It produced a sharp crack followed by a flash of white light, and suddenly the firing port ceased to exist in its original form. The concrete around it fractured outward in a star pattern, with chunks the size of baseballs blowing back toward Donovan's position. Through the dust he could see inside the bunker. The Nanbu machine gun lay sideways, with its operator slumped against the wall. Donovan fired again and again. Each round punched into the weakened concrete, with each explosion blasting deeper and widening the hole. After his 7th shot, the entire front wall of the firing port collapsed inward, creating an opening large enough to observe 3 Japanese soldiers scrambling away from the breach, their faces showing clear shock. To his left and right, the other Marines fired their own volleys. Firing port after firing port erupted in that same distinctive crack-flash pattern, creating a rhythm like a carpenter driving nails, except each nail tore through concrete that had withstood 3 days of bombardment. Donovan emptied his magazine in 90 seconds, firing 15 rounds with 11 hits. The bunker that seemed invincible that morning now resembled Swiss cheese, with its walls fractured and crumbling, and smoke pouring from the breaches. The Nanbu gun had fallen silent after his 2nd shot. The Marines advanced as Donovan reloaded with conventional .45 ACP, saving the explosive rounds for the next hardpoint. They reached the shattered bunker and observed inside. 3 Japanese soldiers lay dead from concrete spalling, their bodies torn from fragments traveling at rifle velocities. The Nambu's operator had died from the first explosion, as the frangible round had detonated against the concrete directly above his head, and the spalling effect had driven a chunk of concrete through his skull. No flamethrower had been required, no satchel charge, and no engineer crawling into killing range. The engagement had been accomplished with a Thompson submachine gun and ammunition that turned fortifications into death traps for their occupants. By 6:45 hours, 48 minutes after the first shot, Donovan's platoon had neutralized 11 bunkers that had held up the advance for 4 days, with 0 casualties. One Marine was wounded by return fire, compared to 14 killed and 23 wounded in the previous 4 days attacking the same positions with conventional weapons. Expanded production and distribution. The word spread through the division by nightfall. Radio operators intercepted Japanese communications describing Bakudan Akuma, or Boom Devil, a weapon that made their bunkers into coffins. The psychological impact matched the tactical effectiveness. Defenders who had felt invincible behind concrete now understood that concrete could not save them. The initial deployment of 840,000 M1 Frangible Grenade Cartridges to Peleliu represented only the first wave of a production program that would expand dramatically through the final year of the Pacific War. Frankfurt Arsenal, operating 3 shifts across 24-hour cycles, manufactured 14.2 million rounds between November 1944 and August 1945, though security restrictions limited distribution to specially designated units with high-intensity cave fighting missions. Production faced immediate bottlenecks. The M42 detonators required hand assembly by technicians with electronics training, a skill set in short supply as the Manhattan Project and proximity fuse programs absorbed qualified personnel. Frankfurt Arsenal employed 347 women from Philadelphia's radio manufacturing sector, many of them former RCA employees who could assemble the microscopic detonator components with adequate precision. Each detonator cost $1.47 to manufacture, compared to 0.03 cents for a conventional .45 ACP cartridge. The composition's C2 explosive presented different challenges. DuPont's explosive department at the Haskell Laboratory in Delaware produced the plastic explosive in 500-pound batches, but the loading process, which involved injecting 48 grains into each copper jacket without air pockets that could cause premature detonation, required specialized equipment that did not exist until December 1944. Engineers adapted pharmaceutical pill-pressing machinery, achieving production rates of 12,000 rounds per day. By January 1945, distribution followed strict protocols established by the Chemical Warfare Service, despite the ammunition containing no chemical agents. Each shipment required armed guards, segregated storage aboard transport vessels, and documentation tracking every crate from Philadelphia to forward positions. The USS Ringle made 4 additional runs to Peleliu, Iwo Jima, and Okinawa between December 1944 and June 1945, carrying a total of 6.8 million rounds that would never appear on standard ordnance inventories. His after-action report, declassified in 1993, described the ammunition's effect as enabling approaches to bunkers that previously required flamethrower teams or demolitions. 3 to 5 rounds through a firing port would collapse the opening or create enough interior fragmentation to neutralize defenders, which saved countless lives. The Japanese attempted countermeasures. Intelligence recovered from Iwo Jima included documents dated March 1945, containing diagrams showing modified bunker designs with angled firing ports intended to deflect projectiles and increased concrete thickness at vulnerable points. These adaptations came too late, as American forces had already adapted their tactics, firing multiple rounds at acute angles to defeat the modifications. At Okinawa, the largest amphibious invasion of the Pacific War, the M1 Frangible Grenade Cartridge reached its widest deployment. The 96-day battle consumed 4.3 million rounds of explosive Thompson ammunition distributed among 7 Marine and Army divisions. Casualty statistics showed the impact clearly. Units equipped with the ammunition suffered 31% fewer casualties during bunker assaults compared to units using conventional weapons and tactics. Supply officers documented persistent problems with the ammunition. Its sensitivity to temperature fluctuations caused approximately 2.3% of rounds to fail, either detonating prematurely or failing to detonate at all. Humidity degraded the piezoelectric crystals, particularly during Okinawa's rainy season, when some units reported failure rates approaching 8%. Field armorer manuals, updated in May 1945, instructed personnel to inspect every round before loading, checking for corrosion on the copper jacket or deformation of the projectile. Japanese radio intercepts increased throughout early 1945. American codebreakers at Station Hypo in Hawaii translated dozens of messages referencing Bakudan Akuma, or dynamite bullets, often with requests for guidance on countering the threat. No effective countermeasure existed. The Japanese industrial base lacked the capacity to retrofit thousands of fortifications with explosion-resistant materials, and by mid-1945, Allied air and naval superiority prevented major defensive improvements. The psychological dimension exceeded the tactical impact in many ways. Prisoners interrogated after Okinawa described the terror of hearing the distinctive crack-crack pattern approaching their positions, knowing their concrete walls would soon fragment into deadly shrapnel. Some positions surrendered after receiving only token fire, with defenders unwilling to endure bunker collapse. This represented a profound shift, as Japanese forces that had fought to annihilation at Tarawa and Saipan were now surrendering to avoid burial alive. The engineering behind the M1 Frangible Grenade Cartridge represented a masterclass in applied explosives chemistry and precision metalworking, pushing the boundaries of what could be achieved with 1940s manufacturing technology. Understanding how the round actually functioned requires examining the weapon system as an integrated whole, including cartridge, weapon, and operator. The frangible projectile's copper matrix used a specific alloy consisting of 88% copper, 8% tungsten, and 4% tin. This combination provided enough structural integrity to survive the violent acceleration of firing, with peak acceleration exceeding 40,000 Gs during the 0.0008 seconds the projectile traveled through the Thompson's barrel, while remaining brittle enough to shatter on impact, releasing the explosive core. Metallurgical testing at Frankfurt Arsenal determined that standard copper-jacketed bullets were too ductile, deforming rather than fragmenting, which could smother the explosive core before detonation. The tungsten particulates served dual purposes. They increased projectile density, improving ballistic coefficient and downrange energy retention. More critically, they created stress concentration points within the copper matrix that guaranteed fragmentation into 40 to 60 pieces upon impact, with each piece traveling outward at velocities between 800 and 1200 feet per second. High-speed photography captured during testing showed the fragmentation pattern resembling a flower blooming in microseconds. The C2 explosive core occupied approximately 40% of the projectile's volume, compressed to 1.66 grams per cubic centimeter, dense enough to remain stable during firing, but not so dense that detonation became unreliable. The 48-grain charge, equal to approximately 3.1 grams, generated a detonation velocity of 6,400 meters per second and a detonation pressure of 180,000 psi when initiated. This seemed modest compared to military explosives like TNT or RDX, but within the confined space behind a bunker firing port, it created an overpressure wave that could rupture organs and render defenders unconscious even without direct fragment hits. Technical specifications and operational limitations. The M42 detonator measured 0.12 inches in diameter and 0.19 inches long, making it one of the smallest functional detonators produced during World War II. Its piezoelectric crystal, barium titanate, synthesized at high temperature and doped with trace calcium, generated approximately 400 volts when subjected to the impact deceleration. This voltage arced across a 0.0008-inch gap to ignite a 2 mg primary charge of lead azide, which in turn initiated the C2 main charge. The system's sensitivity presented the primary operational challenge. Impact velocities below 400 feet per second sometimes failed to generate sufficient detonator voltage, causing duds. Oblique impacts, where projectiles struck at angles greater than 60 degrees from perpendicular, could fragment the jacket prematurely, exposing the explosive before detonation. Field testing on Peleliu documented these failure modes, leading to updated firing doctrine emphasizing perpendicular shots at close range. The Thompson's relatively slow cyclic rate, approximately 700 rounds per minute in full automatic mode, became an advantage rather than a limitation. Faster firing weapons would generate barrel temperatures that approached C2's detonation threshold of 415 degrees Fahrenheit. The Thompson's heavy barrel and moderate rate of fire allowed operators to fire 40 to 50 rounds in rapid succession before heat buildup became dangerous. Thermocouples embedded in test weapons measured peak barrel temperatures of 380 degrees Fahrenheit after sustained firing. Operators learned to recognize warning signs of overheating. The weapon's handguard would become uncomfortable to touch, smoke might rise from the barrel shroud, and most tellingly, ejected brass would show discoloration. Brass normally ejects bright and golden, but overheated cases turned purple-brown from heat stress. Smart Thompson gunners carried two weapons, alternating between them during extended engagements. The ammunition's weight created handling challenges. A 20-round magazine loaded with M1 Frangible Grenade Cartridges weighed 2.8 pounds, compared to 1.9 pounds for conventional .45 ACP. Combat loads typically included 4 magazines, 2 with explosive rounds and 2 with conventional ammunition, for a total weight increase of approximately 3.6 pounds. This seemed trivial till combined with the 67-pound combat load Marines already carried on Pacific Islands. Accuracy suffered compared to conventional ammunition. The frangible projectile's slightly asymmetric construction, unavoidable given hand assembly processes, caused it to tumble beyond 90 yards. At 50 yards, trained shooters could achieve 8-inch groups from bench rests. At 100 yards, groups opened to 24 inches.